Right, I will show you how to solve the simultaneous equation. And for this video, I will explain how to solve the simultaneous equation using elimination method, which is deleting one of the variable by adding or subtracting those equations, okay? So if you see the equation like this, it looks tricky because we've got x and y. But if you see, for example, 5x equal 15. You can say 5 times what gives you 15? 3, isn't it? Right? Or you can divide it by 5 on both sides. So if the equation's got only one variable, which is x or y, and then you can solve the problem easily. Solve the equation easily. Which means if you can get rid of one of those variables, and then you can solve the question, isn't it? Solve the equation, isn't it? Right? Then if you look at this one is the same thing, isn't it? Right? So if you take this equation from this equation, you can get rid of x, isn't it? Does it make sense? So you do this take away this take away this, and then this take away this. Okay? So if you do x take away x, which is cancelled each other, so 0. Negative 4y take away 2y, which is negative 6y, isn't it? And then you got to be careful. 9 take away negative 3. 2 negatives turns into positive, so 9 plus 3, which is 12. Then divided by negative 6 on both sides. Y equal negative 2. Then it's not finished yet. We need to figure out the value of x as well. Right, let's plug this value into this y. Okay? X plus 2 times by negative 2 equal negative 3. This part is going to be negative 4. To get rid of negative 4 from this side, you add 4 on both sides, isn't it? So x equal negative 3 plus 4 is 1. So the answer for this simultaneous equation is x equal 1, y equal negative 2, right? Then if you look at this one, so then can you solve this one? So you can stop the video and then solve it, and then you can come back to here, okay? I will show you the answer. The point is you need to get rid of one of the variable, isn't it? Oh, sorry, this one is wrong. This is x, right? One of the variable. Which variable can you get rid of? This one, isn't it? So if you do, I would say this equation take away from this equation. So 5x take away 3x is 2x. Negative y take away negative y. This turns into positive. So this one cancelled each other. So it's cancelled. 15 take away 7 is 8. X equal 4, isn't it? Then you plug 4 in one of those. I prefer this one because 4 times 5 is 20. 20 is easier to think about for me. So yeah, 5 times by 4 minus y equal 15. This one is a 20. So take away 20 on both sides. Y equal negative 5. And then I just get rid of negative here. So the answer is x equal 4, y equal positive 5. Right? Let's do next one. So can you get rid of one of the variables straight away? Probably not for this one, isn't it? The point of these two questions has the same number in front of the variable, so that you can get rid of it by taking away or adding together. But for this one, you can't get rid of one of the variable by adding or subtracting. In this case, you can make that number in front of x as the same as this one. How? You just simply times by 3 on both sides. You got to be careful. If you times by 3 here, you also have to times by 3 here, and then times by 3 here. If I do 3 times by x, I can create 3x, which is the same as this number, isn't it? So I rewrite this one here. 3x plus 3 times 3 is 9y equal 39. Then 3x here, if you take this one away from this one, and then you can cancel this one, isn't it? So let's say I take this one away. So this one cancelled. 9y take away negative 2, which is negative, negative turns into positive. So this is going to be 11y. And then 39 take away 6 is 33. Divided by 11 on both sides. Y equals 3, isn't it? Right? And then you plug this value into one of those. Okay? Do not put this value in here. It works, but it's more complicated. So I will put this one here. So 3x minus 2 times by 3 is 6 equals 6. Then I add 6 on both sides to cancel this one. 3x equals 12, x equals 4. Then y equals 3. This is the answer. Right, can you solve this one by yourself? Right, I will give you answer now, right? I will double this bottom equation. 10x plus 2y equal negative 10, right? Then if I do this equation, take this equation, take away this equation. I will rewrite this one so that you can see easily. If you do this, take away this, this take away this, this take away this, you can easily solve it, right? So 7x cancelled out. Then, negative 10 take away 4 is negative 14. Divided by 7, divided by 7, x equal negative 2. Then negative 2, you plug it in whichever. Shall we do top one this time? Negative 2 times by 3 is 6, negative 6, plus 2y equal negative 5. And then you add 6 on both sides. Then 2y equal 1, y equal half. I made a mistake here. This one is not 5, isn't it? This is 4. So this one is 4. So, right, okay. Then you add 6 on top to y equal 10, y equal 5. So the answer is negative 2, x equal negative 2, and y equal 5. Okay, next. Right, so this one, can you find y so that you can get rid of one of the variables? This is a little bit different from these 4 questions because you can't really make the numbers the same easily. In this case, I would like you to think about this one. First 2 question is close to this question. 1/4 plus 1/4 is 2/4, which is half. If you've got the same denominator, you add the top number together, wasn't it? The second one is like this. for example, 1/2 plus 1/4. We want to have the same denominator, so you did times by 2 on one side. 2/4 plus 1/4 equals 3/4. Right? The next one, this one, is like this kind of fraction, the same kind of stuff. What? Yeah. Did I make it clear? So I needed to change only one of the variable, which is one of the equation, so that I can get the same number. Okay? But for this one, you can't get the same number by timesing only one equation, like this kind of type. To add those two fractions, you do actually times by 3 here, times by 2 here, isn't it? So you can get the same denominator. So 3/6 plus 2/6, which is 5/6, right? What we did is we tried to make the lowest common factor, lowest common multiple on the denominator, okay? We are looking at the same thing for here. We try to make the same number here and here, or here and here. Let's say here. What is the lowest common multiple of 5 and 3? 15, isn't it? So I times by 3 on top equations, which is 21x minus 15, y equal 27. And then I multiply this equation by 5, then 10x plus 15y equals 35. And if you add them together, you can cancel this one, isn't it? Right? Then now we've got only one variable, and then we've got only number on right side. 63, right? 62, sorry. Then you divide by 31 on both sides. X equal 2. Then you plug 2 in one of those. Let's do here. I don't try not to make a mistake this time. 3y equals 7. This is gonna be 4, so take away 4. 3y equals 3. Then divide by 3, y equal 1. So the answer for this one is x equal 2, y equal 1, right? So can you solve this one by yourself? If you can, stop the video and then you come back when you finish solving it, okay? I will give you answer now. I would do times by 3 here and then times by 2 here, so that I can make 12 and 12 here, right? Times by 3, times by 3, times by 2, times by 2. So times by 3 here, 9x plus 12y equal 15. 14x minus 12y equal 54. Then if you add them together, you can cancel this one, 9. So you add them, 9x plus 14 as 23x. 15 plus 54 as 69, which is divided by 23 on both sides. And then x equals 3. And then you plug 3 instead of this x. 3 times by 3 plus 4y equal 5. This is going to be 9. Take away 9 on both sides. 4y equal negative 4. Divided by 4, y equal negative 1. So answer is x equals 3 and then y equal negative 1. Done. Right, in the next video, I will explain about the substitution method. Okay, so please check it out.